Okay, well that was a test cough. Good morning folks, it's about 11:30, this is Catherine here, Friday the 14th of February 2025, and we've been testing some old vintage valve or vacuum tube radios here. So here's another one. This one's a clipper. Now we had two earlier ones. One was the Bell Colt, which is famous because it seems to have been a law that everyone in New Zealand either needed to have one or your next door neighbour needed to have one. And it was just a typical kitchen, mantle, dining room kind of radio. If you grew up of a certain generation and your parents didn't have one, your school friends' parents probably did. They were made in New Zealand, but some of the dyes to make the cases or something actually came from Australia. Now this is a clipper, and people actually said of the clipper, so it was never as popular. But apparently this was the first sort of New Zealand designed and built, fully New Zealand designed and built radio, maybe with this style with the Bakelite case or something. So we've got this radio. You get it from a garage sale, a deceased estate, whatever. You don't know much about it. We have a quick look at it for any obvious defects. We can't see any dead mice in there or anything. Things been in the garage or something like that. Screws or nails may have fallen inside, be shorting out components, be electrical danger. We can't see anything wrong with this. Be aware, especially with these valve radios without a back on them, this chassis can, under some circumstances, be live. There's usually a wire hanging out for an aerial. That's a bit short for an aerial, but it'll be alright for testing purposes. We look at the cord, see if there's any obvious safety defects with the cord and a plug. Looks like it's been replaced. This wouldn't have been original to 1950s, so at some point someone's put another plug and cord on it. We've got our RCD, our ELCB, our earth leakage circuit breaker, safety switch. This will save your life in most circumstances. We plug that into our system. Our dim bulb tester is made with some homemade parts here, or assembled, and we can put different bulbs in which add a great resistance. So the dim bulb tester, and we plug our radio into the output of our dim bulb tester. This one's had a little bit of insulation cut out of here because some of these side entry plugs, and two of the earlier radios had side entry plugs. This one doesn't need it to fit in. We plug in the dim bulb tester, but our RCD ELCB safety switch is still turned off at the moment. And we plug in the smallest light bulb we've got. It must be a tungsten type, old-fashioned, non-energy efficient light bulb. This is a 15. They're very hard to get now. They're sometimes sold at hardware stores. They go in fridges or sewing machines or something. Now we want to turn on the, that must be the tone, on, volume, turn it up about at least halfway, and tuning in. Now, we've come across a problem already with this one. The tuner seems to have gone wonky, and it's like a wonky donkey, it really is. I've had a look at the tuning thing in there, and it's not moving. So instantly we know there's a problem with this radio. The chassis is going to have to come out of the body, the casing, to fix that. It could be, a lot of these had a string, and it sort of went round and pulled a little thing around, some pulleys. It could just be as simple as that. The string's broken or jammed up. But we can test it for electrical safety in it anyway. We put our smallest bulb in our dim bulb tester. We make sure it's set to the restricted or low power position. And we're going to push this, power on. Okay, that's reasonably bright. I don't know if that's not the full power, I think, of a 15 watt bulb. If there was a dead short in here, let's just say there was a nail had fallen in here, was shorting right out the mains, that would be full brilliance, but it wouldn't blow a fuse. If we look at the voltage we've got, we've got about 40 volts there, 30 or 40 volts. Okay. We put in the next size light bulb. This is a 25 25 watts, tungsten incandescent. Put the power on. Again, that is not the full brilliance of a 25 watt bulb. If it was, it would mean there's something bad happening in here. Defective components, a nail or screws falling in there, a dead rat, whatever it might be. We got about 110 volts there, 120 volts. Remembering that the supply voltage in Australia, New Zealand and many Pacific countries is about 230, 240. Just let that sit for a minute. Often the capacitors in old valve radios go bad. It can help if they sit at low voltage for a little period of time. It helps to somehow, some people say, I take their word for it. So that's about half the voltage. Ooh. When I turned it off, it went to full voltage there. I wonder why that happened. That's curious. Turn it on, goes down to 120 volts. Obviously the light bulb is in series with the phase or the live or the active, depending on what you want to call it. We've got the volume up to about 3/4. Alright, we'll turn that off. And remember, we're keeping an eye out for if smoke's coming out or if there's any smells. And you've just got to be a bit careful, that bulb was just starting to get a bit warm. A tiny bit of a burning smell is acceptable, because there can be dust and things just on the valves. They warm up a bit, and you get a little wee bit of a burning smell. Obviously, if you see physical smoke coming out, or if it's a very bad burning smell, you disconnect the power straight away. We're going to turn the power on now. This is a 1525, so this is a 40 watt bulb. These radios, when brand new, would have been rated about 40 to 60 watts at maximum. So that's how much they take. Now when I look at that, I'm looking at the voltage here. We've got about 155, 160 volts. That bulb is not the full brilliance of a 40 watt bulb. If it was, it would mean that there's very low resistance in the radio, and that the power is going right through somehow, without much resistance of the radio circuitry, because there's a nail in there, or there's a dead mouse, or whatever it might be. But that's fine. And yeah, we've got about 100 and it's fine if the bulb fluctuates a little bit, especially when it first powers on. They can be a bit brighter and then dim down a bit. Capacitors in here are charging up, the valves are warming up, things like that. And what do we got there? About 150-ish volts. So I'm happy with that. If that was a bright 40 watts or getting close to a brilliance, I would think, wow, there's something dangerously wrong in the radio here. Or it could be that in the cable, in the 3-pin plug. But that's fine, that's quite dim. So now we're going to go from low power to full power. Often, even, turned it off again. That went to show full voltage. Now, of course, we know that the station finder, the tuning, is actually somehow defective in this one. The knob is not turning the variable capacitor inside here. It could just be the wee string, has snapped or broken. It's 70 years old. Yeah, so they tend to go around a pulley and they can fall off or whatever. Ooh! Well, it's had time to warm up. Now we've got it sitting right next to the television screen here, which is monitoring the video just to make sure it's going. So it's... Ooh, I was turning it back and back. Taking about 150 watts, shows about 150 volts there. The valve's already a bit warmed up. They're starting to make a noise, which is probably interference off the TV. We can't change the tuning. If it happened to be right on the station, we might get something. 150 volts there, that's quite dim. I'm prepared to give it full power. So we go from low power to full power. Oh. There we go. It's showing 230 volts. I think that's just a plain static, and I'll go back down to lower power in just a moment. I think, and we've turned that off. We'll turn this one off here. Still got the full power. Why is it showing full power? I wonder if there's some kind of problem in there. We'll turn it off at the safety switch. No, I think it shows full power. Oh, I mean, I made this up myself, but I made it up a long time ago. Right. We'll turn the safety switch on again. We've got full power here. Oh, of course, it does do this. I'm refreshing my memory. Now, when we turn it on, our dim bulb. If you've got no reason to believe, look, some people, they just put a 40 or 60 watt bulb in there and just use it like that straight away. It's being extra careful or gentle on the radio to go first with a 15 and then with a 25. You can just put in a 40 or 60. Yeah, 150 volts or whatever. And we know that if there we go, the valves have had time to warm up. There isn't much of a click. When you turn the volume knob back, it's very easy to accidentally turn it right off. Just let it warm up again. And of course the other thing is, of course, these volume controls use like a little carbon track. They get dust in them and just... You may have had old radios, even old transistor radios, and you have to wiggle the volume control a little bit and just wiggle it forward and back a bit. It hasn't come up to make as much noise as it did previously. You wonder if there is something like a capacitor in it that's just gone bad. Or if it's just this dust in this volume control. Which is... It feels a bit ropey, and that's why it's so easy to accidentally turn it off, because you don't really feel the click at the end until it's turned off. That's tone. I wondered if it was just the pointer that had gone wonky, but the tuner was still actually working, but it isn't. I looked in the back earlier and I couldn't see it tuning. So it's definitely got a very ropey volume control. And there's something wrong with the tuner. Sitting stable on about 150. If we go to full power, the valves are definitely getting up to the full temperature. That volume's about 3/4. I can see a small glow in some of the valves there. The dial light is on, and be careful, don't touch the chassis, they can be live in some models. But the fact that it's doing something, I think we will go back to dim, and we'll turn it off, and we will unplug it from the safety switch, RCD, ELCB, unplug it from the dim bulb tester, take our bulb out, just mildly warm. Yeah, so this one, I think the next step with this one, you take the knobs off, you slide the chassis out the back, and see what's obvious with the tuner. If there's anything, as I say, they've got a string. There's sometimes a little spring to keep the string tensioned. They are sometimes absolute little beggars of things to get back into place. With different models, a little bit different. But yeah, and purely as a test, a person could manually, with this out of the case, just turn that tuning. It is completely unplugged. If this is the plug, it's safe. You could just with your finger gently move that tuning capacitor a little bit and see if you could get it onto a station. So that might be a another task for another day. So we tested 2 radios and they both worked, and this one sort of worked. It might just be nothing more than the tuning, that it's off the station, and that we need to pull this out to get to that string that turns a little pointer. And well, it does 2 things. It moves the pointer, but also it moves the actual tuning capacitor, which is what changes your station finder. So that's not moving. At first I thought it might just be the pointer that was defective, and that if it was still moving this, that would be fine. You could tune in different stations, you just wouldn't have the pointer. But the fact that it's making a reasonable volume out through the speaker shows that certainly lots of parts of the radio are working, and it might just be the tuner. Of course, it could have other problems that we can't tell just at the moment. This kind of homemade dim bulb tester is only it's only a basic test. Now I'm wondering if what we might do, just as a curiosity, the way they work is, of course, the power has to go through the light bulb before it can get to the device. Yes, but anyway, so they can be used to help test mains electric equipment if you don't have a Variac. Variacs cost a few $100s. Obviously most proper workshops would have one. And this is homemade from parts. There we go. 2 radios successfully tested. This one, we've got our piece of blank paper here. We're going to make some notes about this right now. We'll give the date. We'll test it. We'll say that from the audio point of view it seemed to be working, but the problem is that it is the tuner needs fixing. Once the tuner's fixed, we can test it again. There may be other problems that don't show up just yet. Now this is the end of the 3rd video in a not really a series of how using a homemade dim bulb tester can be used to test appliances such as these vintage valve or vacuum tube radios. So you do need to use old type tungsten, the non-energy efficient light bulbs. You can either have a range of 15, 25, 40 and maybe 60 or 75. A lot of people will just put in a 40 and just do it that way. And when you turn it on, it's fine if the bulb comes bright for a couple of seconds, but you then expect it to dim down to be quite dim. And then when you flick the switch that is completely disconnected to full power, the light should go out, and you're then delivering full power to the radio or the other appliance that you're testing. So there you go, you can make up a dim bulb tester. Now I think about it, I can't remember how I wired the voltmeter across. Which particular contacts. I know that this has to be in your phase. You take basically an extension lead and this goes in your phase wire. So you've got phase or active or live, depending on what you want to call it. coming in, plugs into wall outlet or the safety switch, RCD, and this goes to your appliance. So you can cut up an old extension lead. This one looks like it's made out of bits of 2 different leads because they're different colours, and a lamp holder. I've seen much tidier units of this, all in one nice little unit, but without the voltmeter. Okay folks, that's all. And be safe. Electricity can kill you.